Okay, so last class we discussed the parts and pieces of isosceles triangles. Now, I just wanted to review real fast a few of the main ideas from what we talked about. So in an isosceles triangle, we know that we have at least two sides that are equal, right? So if you take a look at this diagram, they're marked with the two dashes. Remember, we mark equal sides with dashes. In this case, they're double dashes. So the two equal sides would be called the legs, right? The different side is going to be called the base, right? Now, the one thing I want to make sure we stress is that the base is going to be your different side. Base does not always mean bottom, because we could take this triangle and, turn it, spin it, reflect it. So it's not always going to be sitting on its base, is what I usually like to say. All right, so the base doesn't mean bottom. Base is the different side. Legs are the equal sides. Now, if you remember what we talked about in class, the base angles are called the base angles because they're attached to the base. Okay, but something really important happens with the base angles. So if you look straight across from the base angles, you will see the two equal legs. Therefore, if the base angles are always across from the two equal legs, then the two base angles will always be equal. All right, so let's look at an example down here below. Let's say that we are told that side AB is congruent or equal to side BC. So now that would make this triangle automatically at least isosceles, right? These would be the two equal legs, right? And then we would now need to go find the different side, the base, right? So the base being down here would be side AC. Now, if you take a look, what would be the two equal base angles? Well, the two angles attached to the base would be angles A and C, right? Another reason for that would be, or way to remember that would be, if the base is segment AC, well then the base angles are angles A and C. So they match the side that is named the base. Okay, so I'm gonna go back and mark that. We're gonna go maybe, double arcs. Okay, so I have my two equal base angles, and then I also have my base, which it's attached to. All right, now just to give you a numeric example, let's say, angle A was 40 degrees. Just try to keep this real simple. Well, think about it. We just got done saying that the base angles are the two equal angles attached to the base. So can we find other angles? Well, how about this? If angle A is 40 degrees and across from the double dash, then what other angle would be the same as angle A? That would be angle C, and it would also be 40 degrees, right? Because it's also across from the double dashed side. Now, can you please go find the missing angle B? Right? We should know that every triangle has a sum of 180 degrees. We have 40 here, 40 there, which is a total of 80. So I'm going to subtract and get my sum of 180. There we go. So now I have an isosceles triangle with angles 40, 40, and 100. Right? And we could even classify this further. It would also be what other type of triangle besides isosceles? It would be isosceles and obtuse, right? Because we have that one angle that's more than 100 degrees. Okay, so now let's take what we just talked about and let's give a few of these questions a shot here. So we're going to be working on, this is actually part 2. So this is a document that you guys have, all right? Now we're going to skip numbers 1 and 2. You guys are going to try 1 and 2 on your own, but I'd like us to skip ahead to question number 5, okay? So what I'd like you to notice here is in the directions, right, they tell us the triangle BAD is isosceles with base BD. So that's going to be the case for both of these diagrams. So what I think we should do here is we should go label this, right? So if they're telling us this is isosceles with base BD, then BD is the different side, right? So if this is the base, then that means these two sides will be equal and this will be different, right? Because these are your legs. Okay, and then I'm gonna draw the same thing on the next diagram. okay? But let's remember one also really important thing. What do we know about the angles in any isosceles triangles? Any isosceles triangle is if we have two equal legs, we should have two equal angles. Now, remember, the two equal angles are the base angles. They're the two angles attached to the base. So now I have that information labeled, and I should definitely do the same thing here, right? And now I also want to go ahead and put my algebra on here, okay? Now be careful here. All right, I'm just going to go back a little bit. So be careful here, right? These are obviously angles. Look at the notation here, right? We got the little angle symbols in the front. So I'm going to go ahead and I'm going to label that information, but then in another couple minutes, we're going to go deal with part B, but these are sides, right? There's a difference. Angles we know add up to 180 degrees in a triangle, but sides don't have a restriction. They can add up to anything. So what I'd like you to do is just kind of take your time here, all right? Maybe you might have to hit the pause button, okay? But I'd like you to go ahead and label each diagram with everything you see here. Once you label everything you see here, let's go try to tackle part A. So now A asks us to find x, so we're going to solve for x, and then the measure of each angle. So what I want you to do is just take a look at this diagram with me, okay? We said that BD was the base, and BA and DA are the equal legs, right? So here we go, one more time. Attached to the base are your equal base angles. So my question to you is this: are these two angles equal? And I'm going to say no, right? Look at your diagram, look at your markings. Angles B and D are equal. Angle A is different because guess what? A is across from the different side, right? So that angle is also going to be different. So I can't just, set these equal just because I feel like it. I have to take a look at my markings. Now, if you notice over here, I don't have anything labeled for angle B. But we know that angles B and D are the equal base angles. So what can I label angle B? Well, I can go label it the same thing as angle D. So that's 16x plus 24, right? So now we can take what we've been talking about for the last few days and say that we know that the sum of the angles in all triangles add up to 180 degrees. So this is going to be an example of part plus part plus part equals 180. Okay, so I'm going to go set that up. Okay, that's going to be 16. It's going to be long and messy, but we're going to clean this up real nice. So here's my two equal angles. Plus 32x minus 8 equals 180. So all three of those angles adding up to 180. Right? Now I can simplify by combining like terms. So that'll be 16x, 16x, and 32x. That's 64x, right? And I also have plus 24 minus 8. So 24 plus 24 is 48. Minus 8 is 40. So it actually cleans up to this nice simple equation. What I'd like you guys to do is, please go solve this and find the value of x. All right? Now I do have this answer key already written up here, so what I want to do is just kind of skip over to that and check it out. Now, if you solved correctly, you do get this kind of funky decimal right here, 2.1875. And I'm just going to say, you know what? Leave it. It doesn't go on forever. It's not like it's like 2.3 repeating forever. It just has 4 decimals. And in my opinion, guys, leave it. Here's why. What I'd like you to now do is take 2.1875, and I'd like you to go plug those in to find the measure of each angle. So for example, you're going to take 2.1875 and plug it in here for angle A and here for angle D, which should be the same as angle B. Okay, so let's start off with this. What is after plugging this in, what's the measure of angle A? All right, and I think we should get 62 degrees. Okay, so actually that kind of messy decimal right there, 2.1875, actually gives you a nice whole number answer when you plug it in. Okay, so we're still on question 5. Now we're going to go try part B, but this is a big difference here, okay? It's the same markings, right? Same markings. We have the two equal legs, and then we have the different base, okay? However, they're giving us side lengths here. These are not angles, obviously, because we don't see the angle symbol in front. So the length of AB is equal to this, etc., etc. Guys, take a second if you have to pause. Go label your diagram as you see here. All right, now, there's a really common mistake that some students make, and that is, hey, let me just add up all three sides and set them equal to 180. Now, that doesn't make sense, right? Because, think about it. These aren't degrees. We're not talking about the angles on the inside, right? They're not restricted to 180 degrees, right? These are units. These could be centimeters, feet, meters, miles. So what I want you to understand is, guys, when we add these up, that's perimeter. Perimeter could be anything. But let's take a look at our markings here. Do we know any relationships between the side lengths here? Well, I know that 20y is different than the other two. All right, that doesn't really help. But if you look at my markings here, we know that we have two equal legs. So even though they give me three things, I don't have to cram three things into my equation. I want to just look here. These two legs are equal, so I'm only going to use that bit of information. So we're going to really say this is part equals part. So 12y minus 10 equals 7y plus 40. Right? You guys should be writing this down on your papers. Okay, so what I'd like you to do is please go ahead and solve this equation, and let's go figure out what the value of y is. Now, if you guys have solved correctly, hopefully you ended up getting y equals 10. This is the way I did it. It doesn't have to necessarily match exactly the way you did it. But now what I'd like you to do is take just like we usually do, take your findings, take the fact that y equals 10, and go plug it in to find the lengths of each of the other sides. Okay? What did you get for the base? Well, let's see. If we substitute our values for a 10 for each of those, we get 200 for the base. All right? And we're getting 1/10 for each of the legs just by plugging that in. Okay? And the last question down the bottom says, is BAD also an equilateral triangle? And I'm going to say, obviously not, right? Because we didn't get three equal sides. All right, so just take your time, guys. Make sure I'll zoom out here. Make sure you have all this information written down and copied down on your papers. Okay, on the same page, we're going to actually try question number 3 here. But now, as you can see, we have a triangle inside of a circle, okay? They're also calling this circle P because that's the center. And then they give us some information. So I'm going to come back to this question in a second. What I'd like to do is remind you of what is really important in a circle. You know, you have a center point, right? The diameter is the full distance across. But I want to take a look at this point, this segment right here, the radius. Let's remember that the radius in any circle, right? The radius in any circle is the same no matter where you kind of swivel this thing around or rotate it, okay? So if the radius is here, right? Whoops, I'll just use it 1 dash, right? If the radius is here, then if I have another radius, a completely separate radius, then guys, those are always going to be the same. Those are going to be equal. So I could even mark those equal. So when we look at this diagram, when we look at this diagram right here, they do tell me that we have circle P. So that means P is the center. Now I want to ask you, where are the two equal radii, right? So yeah, from the center to U, so from P to U, that should be the same as P to D, right? This is not a radius because it's not attached to the center, right? It would have to be attached to the center. So take a look. What kind of triangle right now is PUD? Well, yeah, sure. It's isosceles, and these are your two legs, right? Two equal legs. So if those are your two equal legs, then what would we call side UD? Well, yeah, that would be your base. That's the different side. So you got your two equal legs, PU and PD, and the non-equal side, the base. Now, what would be the two equal base angles? Well, yeah, we would just simply mark the two equal angles that are attached to the base. So angles U and D would have to be the same. So let's give this question a shot here, right? They're telling us the measure of angle P is 56. Well, that's right here, okay? That is the different angle because that is across from the different side, right? These would be the two equals. So let me go label that in my picture. So that's 56 degrees, right? So let's think about this. We know that the sum of the angles in any triangle is 180 degrees. So I'm going to subtract 56 from 180, and let's see, what does that give us? 124 degrees left over. But now I have to split that 124 equally between two angles. So guys, what would be the measure of each of angles U and D? Well, let's go take a look. Right, yeah, each of those angles would be 62 degrees. Okay, so let's try another example of this, but now including some algebra, right? So if we look here, once again, we have circle S, right? And remember that symbol is circle S. So S is the center of the circle, which means there's one radius and another radius, right? So those have to be the same length. So I'm going to make sure we mark these each and every time. Now, guys, they're also giving us angle information, right? The measure of angle A and the measure of angle M. So what I want to do is I want to go right to my diagram, and before I even label that other stuff, I want to make sure that we recognize that, once again, this is an isosceles triangle. So my equal sides are called the legs, and the different side is called the base. Also, really important, attached to the base are your equal base angles, right? So I want you to maybe hit the pause button on this video, all right, and go ahead and label what they gave you here. All I did was just take that information and label it here. Now, what I want us to do is look at our markings. Okay, this is not one of the examples before where we added all three angles and set it equal to 180 degrees. They didn't give us anything about this angle, okay? But if you just follow your markings, guys, what do we know about these two base angles? Well, yeah, if you look at your markings, they're equal. So that's the equation we're going to write, okay? So we're going to set up 8x minus 18, you guys should be writing this down, equals 35 minus 2x. Okay, please go ahead and solve this equation. I'm going to give you a little hint, right? Decimals do happen. So see what you get when you solve for x. Okay, now if you solve for x correctly, you do get 1.7. Now what I'd like you to do is please take your numbers and plug them into the equations to get your angle measures, right? So you're going to plug that 1.7 in here, 1.7 in here. Okay, and then I'd like you to go find what is the measure of angle S after you plug in 1.7 into these two angles. Okay, and if you do that correctly, right, plugging 1.7 into each of these gives you 31.6 degrees each. Okay, decimals happen, that's okay. And we're happy because they worked out to be equal. How do we find the last angle? Well, we're going to subtract these two from 180. Now, guys, remember, drawings are not always to scale. So even though this doesn't look obtuse, that is, in fact, our answer. Okay, last one here, guys. All right, now I want you to notice that we're not talking about angles, right? We're talking about side lengths. So one more time, this is a circle. It has center S. So I'm going to go ahead and I'm going to mark my two radii the same, which makes this an isosceles triangles. These two equal sides are the legs, which makes the different side down the bottom here the base. So what I'd like us to do is go ahead and take that information and let's go ahead and write this all down on the diagram as you see here. Okay, so take your time and let's label this like you see it. All right, now one thing I want to really drive home in this last part of the video is these are side lengths, like I said. So do they have a sum of 180 degrees? No, these are lengths, right? So they're units of lengths like, you know, feet or meters or miles. So they're not degrees, okay? If you add up all three sides of a triangle, that's called the perimeter. The perimeter can be anything, any positive number, right? So we're not going to add these up and set them equal to 180 degrees, which I left you this little message here. But here's what I want us to do. Let's look at the diagram and what relationships do you see? Well, hopefully you notice that, again, like before, we have two equal sides. I don't have to cram this into my equation just because they gave it to me, right? All I want to do is set equal the two sides that are equal. Okay, so let's go ahead and do that. That's going to be 5y plus 12 equals 8y plus 9. All right, so why don't you take your time. I would like you to do the following. all right? Solve for y, and then get ready to plug those values into this equation. Or excuse me, into each of these three sides. Okay, and if you did that correctly, right, then we should get y equals 1, and then AM is 3 units and AS is 17 units. And the last question I'm going to ask you is, what would be the perimeter of the triangle? Okay, and if you substituted your numbers in, right, we would have 17 for AS, 17 for SM, and 3 for AM. All right? So again, they don't have to add up to 180 degrees. We're not talking angles here.